So we'll consider here Castigliano's theorem. Castigliano's theorem first. What does this indicate? Let us take any body here, and it is applying with the load P1, P2, as well as P3, and so on. So this Castigliano's theorem first. What does this indicate? If we just take the partial derivative of the total strain energy. So if we take the partial derivative of the total strain energy in any structure of total strain energy in any structure with respect to the applied force, whatever the forces are going to applied, or the moment, that will give you the displacement or rotation. So this will give you displacement or rotation. Displacement in case of there is acting force is acting on it. If there is a moment, you will get the rotation. So this will be at the point of application of the force or moment. So at the point of application of this any force or moment, in that case we will get in the direction of that particular applied force or moment. So if we just consider this is a particular body P1, P2, P3, and let us consider that these are the P1, P2 and P3, they are the forces acting on it, and because of these forces there will be deflection, and let us consider this delta 1, delta 2 and delta 3. They are the deflection or the displacement, we will say displacement. In that case, this strain energy will be equals to U equal to P1 into delta 1 divided by 2 plus P2 delta 2 divided by 2 and P3 delta 3 divided by 2. So if we just going to solve, this is the, if we just going to solve this one continuously, in that case we will get finally, because this Castigliano's theorem first, what does this indicate? So it indicates that if you have this delta U, means partial derivative of this strain energy with respect to the applied force, so this will give you the displacement. This will give you the displacement. So this is how the final part we will get partial derivative of strain energy with respect to P1. We will that will give you the displacement, and that would be in the direction of this P1. Whatever, if it is in the direction, let us have this direction in this downward. So we will have the displacement in that one. So now let us consider the slope and deflection, that is going to be slope and deflection of beam So if we just consider any cantilever beam, let us consider this cantilever beam. And which, let us say this is A point, this is B point, this is L, and there is a load acting on it. Let us take this one as W. And if you want to take the bending moment here, bending moment at a section, let us take this XX, which is at the distance of X from point B So this would be, let us take this m would be equals to total bending moment at section of distance x from B would be equals to m equals to mx minus wx, because there, let us have, this is the moment is also going to act here. So this mx minus wx, w into x, so let us consider this mx is because of the bending moment due to the external loading. Now in that case, if we just consider the strain energy due to bending, if we just consider the strain energy due to bending, this u will be equals to integration 0 to L m square by 2ei into dx. So let us take a derivative of it, partial derivative, delta u by delta w would be equals to integration 0 to L, this is would be m by ei multiplied by delta m by delta w into dx. Now we know that delta m divided by delta w, which is equals to minus x. So because of this, finally what we will get, delta u divided by delta w, which is equals to this delta, that is called as a deflection, and this would be equals to integration 0 to L minus mx divided by ei into x dx. So this is how the deflection is going to be, we will get the deflection, the equation of the deflection we will get in terms of moment mx, and in the same way we will get the slope as well. So let us consider that there is a beam, cantilever beam acting, there is a load acting on it. There is a moment MO, let us consider this as L, this point is A and this point is B. In that case we will take the moment, so moment would be equals to, at this let us have the distance of x, m would be equals to mx minus m, or mx is again the moment because of the external loading, and mo, it is a fictitious moment we can say. Now in the similar way, if we just solve this one, strain energy due to bending, so we'll have u will be equals to integration m square by 2ei into ds here, into dx. And finally if we just solve this, just like the deflection we got, delta equals to integration 0 to L minus mx by ei into x dx. Now here theta, that is called as a slope, we are going to get the slope. So theta would be equals to, say, delta u divided by delta mo, that is equals to integration minus mx upon ei into dx. So this is how the theta, that is the slope, what we call, we will get. Now using this the equation of slope and deflection and this Castigliano's theorem first, we'll solve the problems.